So students, today we are going to learn about third lesson from the paper first, science paper first, and that third lesson is their chemical reactions and equations. So we'll start. How much you are knowing from there we'll start. So everyone is knowing what is meant by atom. Everyone is knowing what is meant by atom. So from that atom only we'll start. So everyone is knowing what is meant by atom. So atom is the smallest particle of matter and it is smallest indivisible particle of matter. What is the atom? Smallest indivisible particle of the matter is called as atom. So after atom, next point is the element. After atom, next point is the element. So we are knowing about element. Element is the purest form of the substance and which has only one kind of atoms. Element is the purest form of the substance and which is having only one kind of atoms. So again in the textbook some questions are asked. In the textbook 2-3 questions are there in the introduction only, and in that question first question is there, what are the types of molecules of element and compound? Question is there, what are the types of molecules of element and compound? So next term will come, that is molecules. So when you will say molecule, when atoms of same element or atoms of different element will combine, they will form the molecules. So molecules, when atoms of same element or atoms of different element they will combine, they will form the molecules. So what do you mean by molecules? There are two types of molecules. There will be molecules of element. Molecules of element. So we are knowing elements. Elements are the purest form of the substance. Element is the purest form of the substance and which has only one kind of atoms. So when there will be molecules of element, so when atoms of same element, when atoms of same kind of elements, atoms of same elements will combine in a fixed proportion. Atoms of same element. Atoms of same element combine in a fixed proportion, then molecules of element are produced. Molecules of element are formed. So atoms of same element will combine in the fixed proportion and then molecules of the element will be formed. And there are in 9th standard you have studied about types of molecules of the elements. In that these types are there based on the number of atoms. So first type is the types of molecules of element. In that first type is the monoatomic molecule. In that which are the monoatomic molecule? These are inert gases, noble gases. So helium is there, neon is there, argon is there, krypton is there, xenon is there. These are the molecules of element, but in that only one end of the atom is there. So second one is there, diatomic molecules. Diatomic molecules. We are studying the molecules of element. Diatomic, in that H2, Cl2 is there, Br2 is there. So hydrogen is there, chlorine is there, bromine is there. These are the molecules of element, but diatomic molecule because it contains 2 atoms each. Next one is the triatomic molecules. In the triatomic molecules, example is the O3, ozone. Example is there O3, that is ozone. Next one is the fourth one, polyatomic molecules. So in that polyatomic molecule is there, S8 is there, S8. sulfur, molecule of sulfur. In that 8 sulfur atoms are there. So these are the molecules of element. So do you understand? Molecules of element, only one kind of atoms are there, and based on number of atoms, these are the types of the molecules of element. So next thing we are going to study about molecule of compound. Molecule of compound. So molecules in the next term is the molecule of compounds. Molecule of compounds. So when you are saying compound, when 2 or more atoms of different element, they will combine in a fixed proportion. When 2 or more elements, 2 or more atoms of different elements combine in a fixed proportion, then molecule of compound is formed. Molecule of compound is formed. So when 2 or more atoms of different elements, they will combine in a fixed proportion, then they are forming molecule of a compound. So in that molecule of compound, there are different types. Like that, based on the atom, these are the types. So first type is there. In that types, diatomic molecule. Diatomic molecule. Diatomic, in that 2 atoms are there. Example, you can take HCl. In that hydrogens 1 and chlorines 1, but these are the atoms of different element. These are the atoms of different element. Second one is the triatomic molecule. The example, you can take H2O molecule. In that hydrogens 2 and oxygens 1. So triatomic molecule is there. Third one is there tetratomic molecule. In that, how many atoms should be there? 4 atoms. So example, you can take NH3, ammonia. Example is there ammonia. And next one is the polyatomic molecule. Polyatomic molecules of compound. In that you can take example sugar molecule, carbohydrate C6H12O6. These are the molecules of compound. So I think you have understood molecule of the element and molecule of the compound. So these are the 2 terms, and specifically if you consider elements are classified into metals, non-metals and metalloids. Before this we have studied. So next thing we are going to study, next question is there in case of the textbook. Second question is there, what is the valency? What do you mean by valency? So in case of the valency definition, and next term we are going to learn, and that term is their valency. And valency you have studied before this also. What do you mean by valency? That valency you have studied before this also, and that valency, next term valency. Question is there, what do you mean by valency? So when ionic compounds are formed, when ionic compounds will be produced, during the formation of the ionic compounds, some elements are losing electrons and some elements are accepting electrons, and they are forming ionic compound by forming ionic bonds. So what is the valency? The number of electrons loosed or gained, number of electrons loosed or gained by atom of an element. Number of electrons loosed or gained by atom of an element during formation of during formation of ionic compound. During formation of ionic compound is called valency. Number of electrons lost or number of electrons gained by atom of any element during the formation of ionic compound is called as a valency, and valency is a term and it is a basic term. Okay, next thing is there. Next point we are going to study. Next third question is there in the textbook, in the introduction only. That question is there. What are the requirements of writing molecular formula for compound? Molecular formula of different compounds. So requirements. Next term is there. Requirements of writing molecular formula. Requirements of writing molecular formula. So when you want to write a molecular formula of any compound, suppose you want to write molecular formula of any compound, in that different terms, different things are there. First thing is there, in the molecular compound you should know symbols of the elements and symbol of radicals. First thing is there, you should know symbols of the elements and symbols of the radicals. Like that, if a sodium ion is there, sodium ion, you should know Na plus. Second thing is there, you should know valency of that, valency of atom of an element. Valence of that particular element you should know. What is the valence of that element? That one you should know. Next one is there. You should use crisscross formula, cross multiplication method. You have to use cross multiplication method to write the molecular formula. And another thing is there. Example we take, suppose sodium's atomic number, sodium ion is there, Na plus and Cl minus is there. So valence is there 1 and here valence is 1, and if you do cross multiplication then you will get NaCl. This is the compound. So for that you have to use cross multiplication. Then fourth point is there. While writing the chemical formula, one trick you have to use, if you will write radicals, their valence you have to write, and after that while doing the cross multiplication, if you will take another example, suppose you will take H plus and O2 minus, valence is there 1 and valence is there 2, and if you do the cross multiplication and you will get if you do the cross multiplication you will get PH2O. So while writing molecular formula, what you have to do while writing molecular formula, write valency as a subscript, to the right of the symbol. So suppose you are going to write any molecular formula, suppose you will write the Na2SO4. So these 2 and 4, these are the subscript. 2 and 4, these are the subscript. In that, how you are going to write? Na's valence is there plus, and SO4 was minus 2, minus is there, valence is there 2, and valence is there 1. And if you do the cross multiplication, you can write Na2 and this SO4. So like this way, these things are necessary for writing the molecular formula of any compound. So next term we are going to learn, and that next term is their chemical reaction. Next term is their chemical reactions. So in case of the chemical reaction, you can do the definition of the chemical reaction. Chemical reaction is a process in which chemical reaction is a process in which reactant react together and they give rise product. Chemical reaction is a process in which reactant react together and they are giving product. They are giving new substance. This is chemical reaction. So little change, little difference we are going to study. Next term is their chemical reaction. Okay, in that two terms on 2 points only we are going to discuss, and later on these points later on we are going to discuss in detail. So first thing is the in the chemical reaction new substances are produced. Chemical reaction, in that new substances are produced. New substances are produced. Second thing is the chemical composition. Chemical composition of reactants. Chemical composition of substances changes. Chemical composition of substances changes, and chemical composition of newly formed substances remains same. Chemical composition of substances changes, and chemical composition of newly formed substances remains unchanged. That means during the chemical reaction, chemical composition of the reactant changes. Whose chemical composition changes? Reactants. And whose chemical composition will remain same? The chemical composition of newly formed substances, that is product. It will not change. Products remain same. Another thing is there. Second point, in that third point, in that physical change, you will consider the physical change. In the physical change, chemical composition of substance remains same. That means chemical composition of substance does not change in the physical change, and it is a temporary change. Physical change is a temporary change, and this chemical change is a permanent change. It is permanent change. So these and the examples we'll see in case of the chemical change and physical change. Chemical change is in that milk get converted into curd. It is a chemical change. It is irreversible change. And in case of the second example, ripening of fruit is also chemical change. Once fruit will get ripened, it will not become a raw mango. Next, in case of the physical change, examples are there. Conversion of water into ice. If you cool the water, it will get converted into ice. Only state of the matter, state of the substance will change. And evaporation of water, this is another example of physical change. So after this, we are going to learn next point, and in that 5 activities are given in the textbook, and in that 5 activities we are going to learn. In that 5 activities, see, 5 activities. Which activities are given in the textbooks? So in that first one is there. We'll make columns. 5 activities are there. First activity is there. You have to take one conical flask. You have to take one evaporating dish. Then you have to take a burner. You have to take tripod stand, and some chemicals you have to take. We'll study one by one. Suppose first one you will take a powder of powder of calcium carbonate. You have to take powder of the calcium carbonate. You have to take the powder of the calcium carbonate, that is limestone. You have to take. What you have to take? Limestone. Limestone powder you have to take. If you will take limestone powder and if you will take it to your operating dish and if you will heat it, after heating calcium carbonate, you have to heat it with the help of burner, and after heating, what will take place? Some gas will be evolved. Two types of changes will take place, that one we are going to see. So if you heat the powder of the calcium carbonate strongly over the blue flame, then what will take place? One reaction will take place. CaCO3 is there. CaCO3, after heating strongly, it will get converted into CO2 plus CaO. So this one is there, calcium or a limestone, you can say limestone. Okay, and this one is there, carbon dioxide gas. This one is there, solid, and this one is also solid, calcium oxide. So calcium carbonate will break into two other compounds. This is a chemical reaction. So 2-3 points are there in this. First point is there, color, whether color changes here or not. So here no color change. Second point is there, gas evolve or not? Evolve. So here yes, which gas is evolved? CO2 gas is evolved. Temperature change. So you are heating, so temperature change will involve. And the last one is there, what type of change is there? Type of change. In that type of change it is a chemical change. Why it is a chemical change? Because new substances form, new substances produced. So CaCO3 on heating, it get converted into CO2 plus CaO, and this is a chemical reaction, chemical change. Second one activity we are going to learn, and in that second activity, what you have to do, you have to take a copper sulfate solution. In that you have to add zinc dust, and then you have to observe the chemical reaction. So what you have to do, you have to take copper sulfate, that is CuSO4, plus you have to add zinc dust, Zn dust, and you have to observe the chemical reaction. So in this we'll write chemical reaction. Suppose in one beaker, in one glassware, you will take CuSO4 solution, and its color is there blue, and it will add in that Zn dust, then which reaction will take place? So reaction will write first. You are taking CuSO4, copper sulfate, it is aqueous in nature, plus Zn dust, you are taking solid state, then you will get ZnSO4 plus Cu, aqueous, and this one will be solid. So here copper sulfate is their blue color, and ZnSO4 is their colorless. So if you see in this reaction, color change will be there. Blue color will get converted to colorless solution. Here no gas will be evolved, and third thing is their temperature of the assembly, temperature of this particular vessel will increase. Temperature change will take place. And what type of change is this one? This is a chemical change, or it is a chemical reaction. It is a chemical change, or it is a chemical reaction. So in second activity, Zn is added into the CuSO4, and then a blue color solution get converted into colorless ZnSO4, zinc sulfate solution plus copper is given out. So this one reaction is there. Next, third reaction we are going to learn, and third activity is there. In that you have to take potassium chromate plus barium uh, chloride, potassium chlorate plus barium sulfate you have to take, barium sulfate. So next thing, so here third activity is there, you have to take potassium chromate. You have to take potassium chromate, and in that potassium chromate you can take K2CrO4, K2CrO4 plus you have to add barium sulfate, BaSO4, you have to add BaSO4. Suppose in a text tube or in a vessel you take these two solutions. Suppose you will take K2CrO4 and in that you will add, plus you will add BaSO4 solution. Then chemical reaction will take place. Chemical reaction will take place, and what type of chemical reaction will take place, that one we have to see. Which changes will occur, that one we have to see. In case of the reaction, if you write the reaction K2CrO4 plus BaSO4, so both are aqueous, this one is also aqueous, and it will give BaCrO4, it will give BaCrO4, and this one will be a yellow PPT plus you will get BaCrO4 plus you will get K2SO4, K2SO4. So in this also, what type of changes will take place, that one we have to see. So first thing is the color change. In that yellow PPT is formed. Second thing is the gas evolve, no gas evolve. Temperature change, yes. Temperature of the reaction, yes. Temperature of the assembly increases. Next thing is there, what type of change is this one? This one is type of change. This one is a chemical change. So potassium chromate on addition of BaSO4, it will form BaCrO4. Barium chromate will be formed, and it will be yellow colored PPT. It will form yellow colored PPT, and K2SO4 potassium sulfate will be produced. Next one is the fourth activity is there. In that fourth activity we are going to learn. So in that fourth activity you have to take sodium carbonate plus you have to take calcium chloride. So fourth one is there, sodium carbonate. Formula is there, Na2CO3 plus what you have to add, CaCl2 you have to add, that is calcium chloride. You have to add. And if you take these two solutions together, and then chemical reaction will take place. Suppose you will take in a beaker or in a glass vessel Na2CO3 sodium carbonate, and in that if you will add plus CaCl2, if you are going to add, then chemical reaction will take place. What type of chemical reaction will take place, that one will write. Firstly, Na2CO3 the sodium carbonate, it will be aqueous, plus CaCl2, it will be also aqueous, calcium chloride. So this reaction will give it will form twice NaCl. First one will be CaCO3 plus NaCl, and two NaCl molecules will be formed. So this one is their PPT, solid, and this one is their aqueous. So in case of the sodium carbonate and calcium chloride, chemical reaction will take place. Na2CO3 plus CaCl2, it will form CaCO3, and here white ppt will be produced. What type of ppt will be produced? White ppt will be produced. Insoluble mass will be produced plus NaCl will be produced. So this one is the fourth activity. So in this, color change is there, no gas is evolved, temperature of the vessel also increases, and the last one is there, this is a chemical change. This is a chemical change. And next, fifth activity is there. In that you have to take phthalic anhydride. You have to take phthalic anhydride. Fifth activity is there with phthalic anhydride. Phthalic anhydride. So in case of the phthalic anhydride, chemical formula is there, C6H4CO2 twice O. Chemical formula is there, C6H4CO2 twice O. You can write this one like this also, C6 here CO2 will be there, here CO2 will be there. You can write like this way you can express it. Like this way you can express it. So C6 1 2 3 4 5 6, H4 1 2 3 4, CO2 CO2 1 CO2 1, and oxygen. So like this way is phthalic anhydride. And if you will take phthalic anhydride into the evaporating dish, what you have to do, that one we will see. Suppose you will take one evaporating dish, you will keep that evaporating dish on the tripod stand. It will heat, burner you have to take, and here one funnel you have to keep inverted. One funnel you have to keep inverted here, and in this you have to take phthalic anhydride. Here cotton fluid you have to take, and it will heat. Then it will heat this one. Then phthalic anhydride, it will get evaporated. Evaporation will take place. That means solid will get converted into directly vapors. And after condensation again it will get converted into solid. So which type of reaction will take place here? Here will be sublimation process will take place. Sublimation reaction takes place. Sublimation reaction. So what do you mean by sublimation reaction? In the sublimation reaction, solid get converted into its vapors and vapors get converted into solid without getting converted into liquid state. Solid into its vapors and vapors into solid. This is called as a sublimation process. So in this, phthalic anhydride will get converted into vapors, and after condensation it will get converted into solid. So this one, in this, no color change is there. Again, no new substance is formed. Temperature change is, if you are heating, then heat will take place. And last one is that this is a physical change. What type of change is this one? This is a physical change. Phthalic anhydride. So 5 examples we have studied. So now after this we are going to learn difference between physical and chemical change. And after that difference we will study next point. That one is there, writing chemical equation. So difference between physical and chemical changes. So on this side we'll write a physical change, and this side we'll write chemical change. So first thing is that in case of the physical change, new substances are not formed. No new substance is formed. And here what you can write, new substances are formed. Second thing is that in case of the physical change, it is a temporary change. Physical change is a temporary change. And here you can say chemical change is a permanent change. Third one is that physical change is a reversible change. It is a reversible change. And here it is irreversible change. That means ice can be converted into water and water can be converted into ice. So another thing is the fourth point is the chemical composition remains same. In the physical change, chemical composition of substance does not change, it would remain same. And here in the chemical change, chemical composition of substance changes. Next thing is there, fifth one is there, no breaking and making of bonds takes place. Here old bonds are not broken and new bonds are not formed. No making and breaking of the bonds takes place. In the chemical reaction, chemical change, making, breaking and making of the chemical bonds takes place. So here in case of the reactant, chemical bonds are broken, and in the product, chemical bonds are formed. So sixth point is that only state, size, shape of substance changes. And here no change. Here color will change, changes. You have seen. Then the next one is the gases evolve. Color changes, gases evolve, and as well as new substances are formed. So in the chemical reaction, color changes, gases evolve, and temperature changes also involved. Temperature will also increase. So these are the difference. This is the difference between chemical and physical change. So one more time we'll see the difference. Physical change, no new substances formed. In the chemical change, new substances are formed. In the physical change, it is temporary change. In the chemical change, it is permanent change. Next one is the third one. Physical change is reversible change. Chemical change is irreversible change. Fourth one is the chemical composition of substances remains same. In case of the chemical change, chemical composition of substance changes. Fifth one is there no breaking and making of the bonds takes place involved in the physical change. In the chemical change, breaking and making of the chemical bonds takes place. And 6 point is on the state, size, shape of the substance changes and in case of the chemical change, color of the color in the chemical reaction changes, gas is evolved or temperature change is involved. So next point we'll see.